Today we're going to be learning about some natural phenomena. This is a very easy lesson, but there is like a lot of things to cover up. So let's get started. So what is some natural phenomena? In class 7 you read about winds, storms, cyclones. You also learn that cyclones can cause a lot of damage to the human life and property. You also learn that we can protect ourselves from these destructive phenomena to some extent. And in this chapter, we shall discuss two other destructive natural phenomena. These are lightning and earthquakes. We shall also discuss what steps we can take to minimize destruction caused by any of these phenomena, which are like earthquakes, lightning, cyclones, storms, etc. So first, let's start by learning what is a lightning. So you might have seen sparks on an electric pole or the lighter that we use to light a stove when we cook. The wires. So what happens is the electric pole when the wires become loose. For example, you're just plugging a wire for your what's that? For your wire for your computer, and then if the wire gets loose, you may see some like small sparks. This phenomena is quite often when the wind is blown and shaking the wires. You might have also seen sparks when a plug is loose in its socket. Light is also an electric spark, but on a huge scale. Lightning is an electric spark on a huge scale. This might be as defined, so make sure you learn that. In ancient times, people did not understand the cause of these sparks. They were therefore afraid of lightning and thought that the wrath of God was visiting them. Now, of course, we understand that lightning is caused by the accumulation of charges in the clouds. We need not to be afraid of lightning because we have to take few precautions. Now, at the long ago, people were thinking that it was the wrath of God. That God is coming and saying that this person is not good and he's putting the lightning. People think that way. We always know the myths. So what is a lightning? How is lightning caused? It's caused by accumulation of two or more clouds. It's accumulation of charges on the clouds, and we do not need to be afraid of lightnings. We just have to take precautions to protect ourselves from the deadly big sparks and the sparks that Greeks knew. Coming to the next topic, sparks that the Greeks knew about. In ancient Greeks, as an earlier 600 before Common Era, that when like amber is kind of like a resin, or like just kind of like wool. It was rubbed with fur and it attracted light objects such as hair. You might have seen when you take woolen cloths or polyester clothes of your if you just remove them, you can see like your hair strands, like would stand up on your head. If you take even clothes in the dark, you can see a spark and hear a crackling noise sometimes. In 1752, Benjamin Franklin, a very interested and very brave scientist, an American scientist, showed that lightning spark from your clothes are essentially the same phenomena. However, it took 2,000 years for this realization to occur. So, who is Benjamin Franklin? He is an American scientist who showed that lightning spark from your clothes is just the same phenomena of the lightning coming from the accumulation of clouds, right? And then the about the ancient Greeks, what did they know when they rub amber and fur? Yeah, you can see like small sparks and all that. Now, what is budgeting? I wonder why they took so many years to realize the similarity. Scientific discoveries, Peli is saying, scientific discoveries are result of hard work by many people. It can sometimes take a long time. I agree, that's really nice. Um, we shall now study about some properties of electric charges. We shall also see how they are related to lightning in the sky. So first, let us perform some activities interesting to understand the nature of electric charges. But let's recall first what you might have played as a game. When you rub the plastic scale on your dry hair and the scale can attract very small pieces of paper. Not only scale, it's just like the comb. When you just comb your hair and then take a paper and you can like cut it very small, and then when you take the charged comb and then put it on the paper, just comb your hair really nicely, make sure it's not greasy. And after that, if you just put it on the piece go take it near to the pieces of paper, it starts to attract. Now, what is this process of charged by rubbing? When a plastic refill is rubbed with polythene, it acquires a small electric charge. Similarly, when a plastic comb is this we discussed this, right? Rubbed with dry hair, it acquires a small charge. These objects are called as charged objects. The objects which we rub together, or they just when we rub together, the objects gets charged, and those objects are called as charged objects. Very easy, right? In this process of charging, here we are taking a refill in a plastic comb and a polythene, and the hair also will get charged. Let's try to charge some other objects that are familiar to you. But before that, let's see this activity. So take a used ballpoint pen refill and then rub it vigorously with a piece of polythene, which is like the plastic bag, and then bring it close to some small pieces of paper. Take care, do not touch the rubbed end of the refill with your hand or with a metallic object because it passes current. You would act like a conductor, right? With your hand or with a metallic object. Repeat the activity with small pieces of dry leaf, husk, and mustard seeds and record your observation. You all can definitely try this if you have time. If you're in a hurry, like going for exams, getting ready, it's okay. You don't need to try it. Just imagine, or you can like see some videos about people how are trying them. Okay, types of charged and their interaction. Now we will select some objects from the table 5.1 for the next activity. Okay, now let's see what this is. Inflate two balloons and then hang them in such a way that they do not touch each other. Rub both of the balloons with a woolen cloth and then release them. What do you observe? Now let us repeat this activity with used pen refills. Rub one refill with polythene and place it carefully in a glass tumbler and the tumbler as a stand, with the tumbler as the stand. Okay, you all can see what's happening in there, right? Yeah, so rub the other refill also with the polythene and bring it close to the charged refill. Be careful, do not touch the charged end with your hand. Is there any effect on the refill in the tumbler? Do they to attract each other or repel each other? In this activity, we have brought close together the charged objects that were made of the same material, which happens if two charged objects are made of different materials. Let us bring them close to each other and let's find out. Rub a refill and place it gently in a glass tumbler as before. Bring an inflated charged balloon near the refill and observe. Let us summarize what we have learned till now. The observations are a charged balloon is repelled as a charged balloon. When we just say that the phenomena of magnets, like charges repel and negative charges attract each other. Like charges attract, which is positive and positive charges repel each other. So positive and positive will repel each other, negative and positive will attract each other. But a charged balloon is an attract to a charged refill. Does it indicate that the charged balloon is different kind of charge on the refill? Can we say then that what are the two kinds of charges that we can also say that like repel each other? While the charges of are different kinds, is it convention to call the charge acquired by a glass rod when it's rubbed with a silk as positive? The other kind of charge is said to be negative. It's observed that when the charged glass rod is brought near a charged plastic straw rubbed with polythene, there is no attraction between the two. What do you think will be the charge on the plastic straw? Your guess. The plastic straw would carry negative charge is correct. The electrical charge generated by the rubbing are static. They do not move themselves when the charges move. They are constituent to the electricity or the electric current. You have been reading about electric current since class 6. The current in a circuit which makes the bulb glow or the current that makes a wire hot is nothing but motion of charges, right? So, what is an electricity or electric current which is static, which is in the same place, which is not moving? What is the name of it? So, the answer to this is the Let's see an activity before that. Take an empty jam bottle, take a piece of cardboard and slightly bigger than the size of the mouth of the bottle, or you can like take a jam bottle, no offense, anything is fine. I mean, at your convenience, whatever you get, you can do it. A jam bottle is the best because everybody can have it. So you can see that just take it slightly bigger than the mouth of the bottle, and then you have to pierce a hole in that so that the metal wires can be inserted in it. You can like extend an paper clip. Just take a paper clip and then open out the paper clip and then cut two stripes of aluminum foil. Aluminum foil is nothing but something we use to wrap our sandwich and stuff like that, and then hang them on the paper clip as shown. Insert the paper clip into the cardboard lid, and then you have to just put through two holes in it and just insert the aluminum foil, and this is called as an electroscope. So the aluminum foil strips receive same charge from the charge refill through the paper clip. Remember that metals are good conductors of electricity. The strips carrying out similar charges repel each other and become wide open. Such a device can be used to test whether an object is carrying charge or not. This device is called as electroscope. So what is an electroscope? An electroscope is used whether to test an object is carrying charge or not. It's called as an electroscope. Thus, we can find that electrical charge can be transferred from a charged object to another through a metal conductor. Touch the end of the paper clip gently with your hand and you will find the charge in the foil strips. They come back to their original state. Repeat charging the foil strips and touching the paper clip. Every time you will find that the foil strips will collapse as soon as you touch the paper clip with your hand. Why does this happen? The reason why the foil strips lose charge to the earth through your body is called, we can say that the foil strips are getting discharged, and the process of transferring the charge from an charged object to earth is called as earthing. So what they're saying is, I know y'all can't understand, I'm saying that the foil strips will just the normal foil strips you have made an electroscope. Then you can see an attraction or repulsion. After you see that, if you want to stop it, just take your hand and touch the paper clip with your hand, and the foil strips just tend to lose the charges that are in it, and then the foil strips, we can say that they are getting discharged, and this process of transferring the charge from a charged object to the earth is called as earthing. You are being the charged object there, you are like a conductor for the electricity to pass through you, and from you, wherever you are standing, it will go to the ground, right? So that is called as earthing. The process of transferring of charge from a charged object to the earth is called as earthing. Earthing is provided in buildings to protect us from electrical shocks due to any leakage of electrical current. Alright, you guys, there is just a little more to cover through and we'll be done. So make sure you guys wait for the part 2, and that's for this video. Make sure like, share and subscribe for more. Bye.